is
All
yours.
right. Okay. Okay. And I'll just go and share my screen. Let's see which one. Okay, it's recording. And now, so I'm just wondering which screen you're seeing. You're seeing the big screen? Okay, good.
Yep.
All right, so I'll keep on going from here. So the work, I mean, I'll be doing what they've done well. They've done badly well, but I'll use the general title of the appallingly bad neoclassical economics of climate change, because I really have not seen anything this bad in the 50 years that I've been a critic of mainstream economics. It was just breathtakingly bad, but I had some awareness. I knew, of course, that Nordhaus had trashed the limits to growth back in 1972 when it came at attacking the World 2 model on which limits to growth was based. But I didn't actually go back and take a detailed look at their work until after I made a positive contribution on the whole issue of energy, which is what this is fundamentally about, using energy in production. So that's a very small, short paper I wrote with Bob Ayres and Russell Standish, my Minsky programmer, showing that you have to effectively use energy as an input to labor and capital. The basic insight was that labor without energy is a corpse, capital without energy is a sculpture. So rather than tacking labor on as an additional factor of production, which is the way the neoclassicals have normally handled it, what you have to do is treat energy as an input. So effectively, you've got it going in as a chain rule into the labor and capital placeholders in production functions, rather than going as an independent third factor. And that's so having done that, okay, I now thought I could actually having made a positive contribution, I could now decide to critique them. And I thought they're going to be attacking the Ramsey growth model and the high discount rate that they use. But I haven't even got there. Okay, I simply haven't got to that point, because there's no point getting there. It doesn't matter what model you used. It's the empirical assumption they've made that would make any model, even a good one, nonsense. And this is why I say it's the worst work that I've read in over half a century of being a critic, because what they're doing is saying, we don't believe it has any real impact on the economy, so let's make up numbers to prove that it doesn't have any real impact upon the economy. That pretty much summarizes 30 years of neoclassical climate change economics. And it's not that they're outright deniers say it's not even happening, or that carbon dioxide isn't a factor. What they're denying it will have any impact upon the economy, and this is the sort of stuff you'll find. So this is the first paper where Nordhaus tried to give an empirical estimate of the damages from climate change that he expected, but he starts by saying for climatic zones, i.e. regions of the planet now in today's climate, non-climate variables swamp climatic in determining economic efficiency. That's completely true and completely irrelevant to the issue of global warming. What the hell is it doing in an academic paper? And then I love this. In that same paper, he says 3 degrees of warming is likely to cause 1/4% of damages to national income. It says, my hunch. Now, what the hell is the word hunch doing in an academic paper? It's just bizarre that this is being treated as scientific work. And then he had a survey he did in 1994. And this is, again, the sort of language that comes out of these surveys, the research in general. Of the 19 people he surveyed, 3 were scientists, one of whom refused to answer the questions because he saw them as so inane, the numerical questions he had posed. He answered other questions. And 10 of the 18 who had answered the full survey were economists, and 8 of them he described as having specializations outside climate change, which means, of course, they're not experts. Now, I'm sure these 2 quotes come from Larry Summers, who's one of the experts he asked. Would take a very sharp pencil to see the difference between a world with and without climate change or with and without mitigation. In other words, it's the second, third, or fourth order issue in importance in the way that they framed it. Now, at the same time, the 2 of the 3 scientists who answered the question Nordhaus posed about how much damage to GDP from an X level of temperature increase by Y year. So he had 3 degrees by 2090, 3 degrees by 2160, 6 degrees by 2165, I think it was, and 6 degrees by 2090 as well. And in each of those areas, the estimates the 2 climate scientists gave were on average 20 to 30 times the estimate that mainstream economists gave. Now, that would be okay in one sense if it was just a fleeting piece of nonsense that got overruled by later elements in the literature. But here's the IPCC from 2014. exactly the same nonsense. 20-something years later, the impact of climate change will be small relative to other drivers. Medium evidence, high agreement. Okay? So the people who are answering this stuff agree with each other that climate change doesn't matter, and they're the ones writing the economic chapters for the IPCC, which fundamentally are the only chapters that politicians and journalists end up reading. And this is the trouble. Despite all the failures of neoclassical economics, they're still taken seriously because that's the training that politicians and journalists themselves have, not STEM subjects, but economics and history, and if they're lucky, and politics and so on. Now, so in writing in 2018, after he got the Nobel Prize, he said a 6-degree increase in temperature would cause a 7.9% fall in GDP. I then had a joint paper rejected from Royal Society by the economists on the basis that nothing as ridiculous as what I critique could ever be published again. And shortly after that came out, these 3 papers occurred, one saying a 3.67% fall in GDP from a 4-degree increase in temperature by 2100. Now, notice the 2 decimal places of accuracy here. Okay, this is the sort of conceit that's got into the literature. I'm waiting for the first paper with 3 decimal places of accuracy. 7.22 from Khan and Mahadi's, and then tipping points reducing GDP by 1.4%. Now, this is saying, in all these cases, this is a comparison of GDP with climate change versus GDP without climate change. This one in tipping points is GDP without tipping points being tipped compared to where they are tipped. And at 6 degrees of warming, they'll add another 1.4% in damages. Now that's this to go through the tipping point they included: the Arctic summer sea ice, Greenland, the West Antarctic, the Atlantic meridional overturning circulation, the Amazon, the permafrost, ocean methane hydrates, and the Indian monsoon. Those 8 factors, who cares? They're trivial. Only 1.4% effect on GDP. And again, the latest IPCC report, again, incredibly good work by the scientists in the chapters by scientists, but this is the stuff that gets read by the economists. Warming of 4 degrees will cause a 10 to 23% decline in GDP by 2100, relative low without global GDP without warming, which means rather than being 5 times larger than it will be today, it'll be 4 times. And that's the sort of trivialization they're doing. Now, scientists, on the other hand, are warning of existential risk at much, much lower degrees. So you'll find this is Hansen and co. saying 2 degrees would be dangerous. Seffen and co., 2 degrees, the tipping point into hothouse Earth. Lenton, it's too risky to bet against them, in a very recent paper saying 3 degrees by the end of the century would be extreme climate change, not the 6 degrees that Nordhaus is talking about. So how do they get the estimates? Well, they simply make them up. And this isn't the first one that I spotted, but it's the earliest in the literature. So Nordhaus assumed that activities taken in carefully controlled environments. Now that's code for under a roof, okay? Because when you look at the industries he included, or undercover, okay, it included all of, pardon me, I pressed the blank there, all of manufacturing, all of mining. That's why I say it's undercover. Okay? Utilities, finance, trade, most service industries, difficult to find major direct impacts. And then the IPCC in 2014, the same nonsense. If you're exposed to the weather, you're exposed to climate change. If you're inside under a roof, you're not exposed to climate change. And notice they're saying things like microprocessor fabrication. Here's an article from just a couple of months ago of the temperature in China during the huge drought they had during summer, meaning they had to shut down microprocessor production, the stuff that he said would be protected from climate change. Now, that's the way that number was built was simply saying we're going to add up damages from different science papers, but they considered nothing from virtually 90% of the economy. This thing, they take a look at the actual total GDP, but they're using the link and very weak link between temperature and GDP today as a basis of saying, well, we can use this correlation to predict what's going to happen with climate change. And this is the first one that I was literally in shock when I read this. I thought this is so stupid. But this is what's actually pushed their empirical work, and no wonder they're coming up with trivial dangers from climate change. So what they're doing is they're saying you can use, I've done a couple of statistical things. I'll come back and talk about that later if you like. But it's simply saying because there's such a little difference in income between North Dakota and Florida, and New York's in the middle, then we can use the 10-degree range of temperature between Florida and Iowa to say what's going to happen with 10 degrees of global warming, which is just insane, but that's what they've done. And the other remarkable thing, economists, hammer the idea of specialization all the time. Who should specialize in creating climate models? Scientists. But they did their own, these so-called IAMs, and they do not include rainfall. So here's from the 2021 paper, which is the one on tipping point, saying AMOC slowdown will have other physical effects, for instance, effects on precipitation, but these have yet to be incorporated in economic studies. Now, the way they rationalize this is the one AMOC paper that they included in that tipping point study, that models assume that other climate variables scale with temperature. Now, what that means is they have an ideal temperature in their model because it's all about weather and it's all about agriculture. So they say there's some ideal temperature for agriculture. So they presume that if you have global warming, if you're too cold, it'll push you towards that ideal. It's too hot, it'll push you past the ideal. And we assume the same thing. There's an ideal level of rainfall. And if you move towards the ideal temperature, you move towards the ideal rainfall as well. Well, that's nice. We should move to that planet. Not the planet we're on. They're just, again, bizarre that they leave out one of the most fundamental elements of climate is not even in their so-called climate models, their IAMs. And then the most recent stuff they've been doing, and I'm going to ape this in a moment now, is they take change in temperature and change in GDP data from a database they put together from 1960 to 2017. This is work by Khan and Mahardis. And they then show that a 0.04 degree increase per year will reduce real GDP capita, again, compared to a much richer world with no global warming, by 7.22%. Now, it doesn't, you'd have to be, well, forget it. If you don't know that's a linear extrapolation, what are you doing watching this lecture? They're simply linear extrapolated what's happened up to 1 degree of temperature increase out to 4 degrees. There'll be no structural change in the climate from another, in that case, 3.2 additional degrees of warming past where we are in 2020. And the consistent thing they do in all their models that excludes those most recent papers I showed, they use where they have data restricted up to 1 degree, they extrapolate that forward using a quadratic. And this is, again, this is through the quotes from the tipping points paper. Now, what this particular part of the paper is looking at non-market damages. So they're saying what happens to the parts of the environment which give you utility, but you don't pay money for. And they're saying that the damage to that side of the society will be matched by a quadratic, which predicts that complete destruction of the non-market biosphere will be only achieved at 17.68 degrees increase in global average temperatures. Now, at 17.68, the president of America will be a tardigrade. It'll be the only life form left on that particular part of the globe. So it's just bizarre that they do this. So why do they do it? Why quadratic? Well, basically, it's lazy. The quadratic is easy to do in cost-benefit analysis. You take the derivative, you've got a straight line. You find where the two straight lines intersect, you've got your point of optimum cost-benefit analysis. So that's the basic reason for it. But what the conceit they have, and it is nonsense, but I'm going to show what happens when you even do nonsense properly, that you can find a footprint of global warming in current data, whether that's believing you can use today's temperature and GDP as they initially did, or now saying it's change in temperature and change in GDP, and then they extrapolate that forward. So what I'm going to do is do the same thing, but extrapolate it with other functions. Now, there have been plenty of articles attacking them. They're using quadratic. This is from 2009, saying there's no justification, empirical or theoretical. Weizmann emphasized that it would trivialize the dangers from uncertainty. And Pendick has really been the most vociferous critic so far, said their damage function is made out of thin air, which is a compliment. Okay, at least it's got some physical foundation. So I'm going to now take what they've done, but do it more correctly. And first of all, I'm not going to use a database I made up. This is a database maintained by the National Office of Atmospheric Administration, NOAA, one of America's great acronyms, and then extrapolate that, not just using a quadratic, but also more appropriate functions for tipping points. So this is NOAA has a database called the $1 billion Climate Weather Damages Database. And this is plotting the data as a percentage of GDP. It goes back to 1980. And those are your annual data points there. And of course, to use this, what I had to do is first of all map from the years to carbon dioxide levels, because I want to isolate not the temperature we actually have, but the component of the temperature that is affected by global warming. Now, this is using a couple of data series on carbon dioxide, quite remarkable that you can see how close a simple exponential from 1750 forward is, where the minimum level in 1750 is taken as 278 parts per million. Because when you look at the data that's been reconstructed by, I've forgotten the actual source of this data, I'm happy to provide it, of course, but from 1750 to 1765, the parts per million are 278. They literally began rising in the year of the start of the James Watt steam engine. So that's when the heavy use of coal began to occur. And from that point on, up from 278 up to about 420 parts per million today. Now, when you do that, of course, you know that carbon dioxide has a logarithmic impact in terms of the amount of temperature saturation it causes. But because we had an exponential increase in carbon dioxide, an exponential times the logistic, the log is going to give you a linear relationship. And it's quite a very tight linear relationship between the temperature anomaly, measured here from 1900, and the level of carbon dioxide. So with 420 parts per million, predicting a 1 degree increase over 1900, which is pretty damn close to what the actual data is. So that's how I know to generate the temperature data going forward to 3 and 6 degrees of warming. So now what I've done, I've taken that data. Now on my horizontal axis, no longer time, it's the temperature change caused by global warming over the 50 years from 1980 till 40 years from 1980 till roughly today. So that's the new data points. Now I then fit that with a quadratic, an exponential, and a logistic. And can you guess which one is which? Okay. In terms of the current data, you simply cannot distinguish them. They've got the same R squared, very low, 0.13 to 3 decimal places. So you simply cannot distinguish them out of the current data. So the only way to say which function is worthwhile is which one more describes what's going to happen with global warming. So those are the 3 functions, very simply derived. And when you look at the quadratic, basically says no damages of any significance really until the 22nd century. But the logistic and the exponential say the economy won't exist by sometime this century. So that's the difference. It's simply how they extrapolate the data. And they're extrapolating using a function which has no relation to the sort of change that we know to expect in terms of tipping points and so on. The blue line is Nordhaus's damage function. This line is the quadratic that I derived from Noah. Of course, the other two are logistic and the exponential. Now, when you then run those into dice, you can't put the logistic because there's no quadratic, there's no polynomial expansion for the logistic function, dice is run in a program called GAMS, and like it's a very neoclassical piece of software, but it can't natively take a logistic. So I could only put a 12th order polynomial expansion of the exponential there in against the quadratic. And those are the 3 damage functions I get out. So the peaky one obviously is the impact of the exponential, and that gives you like a huge peak level of carbon price coming out of it. But the important thing isn't the carbon price, it's what happens to what is their recommendation for the amount of carbon dioxide which actually generate. Because when you feed the quadratic and the exponential function and Nordhaus's own function into dice, these are the trajectories you get in terms of global gigatons of carbon dioxide per year. So the quadratic I use curve function in terms of the amount of carbon dioxide to emit. So you're peaking at almost 70 gigatons in 2100. Ditto for Nordhaus's. The one with the exponential says we should stop producing any carbon dioxide from industrial processes by 2035. Now, what that means, of course, we should use the backstop technology, which is triggered in Nordhaus's model, I think at a price of 384 tons of carbon. Okay, so we start using it as of 2035. There's only one problem. It doesn't exist. And that's the sort of dilemma we should be confronting. They simply can't cope with an existential crisis. Even when you feed that existential crisis into their model, they predict when they're going to continue going on because this magical technology is going to suddenly occur when the carbon price exceeds $384. Now we have to get rid of this framing of being all that cost benefits, and the benefits of reducing climate change are minor and the costs are large. So you would have heard of Stuart Kirk, the then chief of the responsible investment at HSBC. Now, the poor man, by having made these statements, he's no longer working for HSBC. He now writes for the Financial Times. So still ludicrous influence coming out of this. He said investors need not worry about climate risk, and all the logic comes straight out of the economic argument. So it's going to hit future growth in 2100. Worst case, this is he's talking in terms of the 2014 IPCC report, now the economics chapter, 5% of GDP. But then, of course, they're also assuming continuous growth over the whole next 80 years. He said we'll be about 500 to 1,000% richer, if I can quote his intonation on that in his speech. And he said, if you lock 5% of that, who cares? You won't even notice. Now, that really is why, not the only reason, but it's a major reason why politicians and the public haven't taken climate change seriously, because it's presented as a minor danger. That's all they're saying. Okay. Now, so we have to change the framing from minor damages to existential risk. And that's not being doomerist. I think it's just being realistic, because if all people think is a 5%, that's the sort of response you get. You don't do anything. What we really need to do this is regard it like World War II. It's actually World War III. That is World War II again. It has to be an existential risk that we perceive. So you may have seen this paper by Stefan and co. Saying we have been living for over 1 million years in this glacial limit cycle. We've now pushed ourselves away from it. We face the prospect of falling into, from runaway processes, a hothouse Earth environment. Hansen was out just a couple of days ago saying he expects the amount of carbon dioxide we've pumped in already will cause a 10°C increase in temperatures, which would just be off the scale of anything really since the Earth stopped being bombarded by meteors. And whether wildlife could survive that is a moot point. That's the way we have to see it. But I don't think we're going to do that until we actually start seeing gigantic climate disasters coming out of the real economy. Pardon me, I clicked on the wrong button there. I've got a YouTube presentation opening up another window. I'll just shut you and Kirk up. Good. Pardon me. And back over here. My apologies. That was Stuart Kirk's presentation, not mine, that I accidentally triggered. Now, the thing is, why are such stupid assumptions being accepted? And the real thing is, economics has been dominated by crazy assumptions because they detail in debunking economics. Whenever they try to follow through their own logic, they contradict their own starting point. So you have the Sonnenschein-Mandel rare conditions, you can't derive a demand curve. You get the Perron-Frobenius theorem, Vollrath's pricing model is unstable, et cetera, et cetera. They simply make crazy assumptions to get over those issues. And this is Milton Friedman's, the more significant the theory, the more unrealistic the assumptions. And it really has softened their brains to believe that unrealistic assumptions are the sign of a good theory. So they're avoiding these logical and empirical arguments. Now they're using, in this particular case, they're applying this to empirical inventions as well. And in my most recent book, I call it the neoclassical disease. And it's a major reason why economics has not become a science. And it starts again from this innate belief that capitalism can cope with anything and therefore climate change can't be a problem. That's really the mindset. And to trace it back and say, what if they'd known would not have led to this outcome? It's really the role of energy in production. So they use a Cobb-Douglas production function. I know I can go fairly quickly here. So you have GDP, which is basically widgets per year, uniform commodities per year, technology, labor, capital, all raised to an exponent, reflecting the share of the factor of production in GDP. And that's really why you get this stupid, and that's the best word for it, stupid statement from Nordhaus about difficult to find any impacts because energy is not there. Now, when they do include it, and this is one paper that has done it, I found 2 papers so far in the literature that include energy in the production function. They add energy as a third factor, and they give it an exponent based on its share in GDP. Now, when you look at the rate of change that implies, then it's saying if you have an 80% fall in energy levels, you'll get a 5% fall in GDP. That's the mindset. Now, a recent working paper by an American-based German economist, you might know him, Rudy Bachman and friends, saying what's going to happen if Germany loses access to Russian or gas and loses, say, 10% of its energy. Well, it's going to cause a 1.5% fall in gross national expenditure. And they ridicule, in this particular paper, they ridicule the post-Keynesian argument that there's a one-for-one relationship between change in energy and change in GDP. So the top purple line there is the straight Cobb-Douglas production function. With a coefficient of 0.04, you're saying a 10% fall in energy. We'll call a 0.4% fall in GDP with a lower rate of substitution, like 0.04 in a CES function. They could get that up to 1.5, and that's what they quoted. They ridiculed the post-Keynesian because the reason they ridicule it, it doesn't fit neoclassical income distribution theory. So here's they ridicule all the people worrying about it and saying it doesn't hold to academic standards, but of course these are neoclassical academic standards, which is an oxymoron. So he rejected this the Leontief proposition by saying if factor prime markets are competitive, so that factor prices equal marginal products, then the Leontief implies that energy will jump to 1 over alpha, which is a 25 times increase, and the others will fall to 0. These are nonsensical, is his answer. Well, it's true. It would be nonsensical. But the reality is that's what the data shows. When you look at change in energy and change in GDP, it's a one-for-one relationship. So this is World Bank data on gross world products and OECD data on energy consumption, the rate of change of both. I've used exactly the same scale. Normally when I do a graph like this, I have 2 y-axes, just one y-axis. The change is almost 1-for-1. And I think this is from Aldous Huxley. The great tragedy of science, a beautiful theory destroyed by an ugly fact. The ugly fact is what he was ridiculing as a production function is actually the empirical reality you'll find in economic data. But why do they get it so wrong? Well, again, because they're ignoring energy. So just to go this in detail, you have widgets, technology, labor, and capital, constant returns to scale, which I don't object to as an assumption, but they then assume those exponents are the marginal product of labor and capital, without which their theory of income distribution is broken. So they can't bring this in without breaking their theory of income distribution. Now, labor gets 60 to 70, capital 30 to 40. They normally use 0.3. They just haven't moved on because the data has drifted towards from 0.3 to 0.4 for the capital share. And they treat energy as a third factor, as I've shown, and base that on its share in production. But they said the reality is it's not an independent factor. That's what they use. The real thing should energy is an argument about labor and capital. And the best way to bring them in is to say you work in terms of the number of units of labor and units of capital, the energy consumption per unit of labor and capital, EL and EK, and the efficiency with which that is turned into useful work, little EL and little EK. Now, when you take a look historically, the efficiency, the amount of energy that a worker can put into consumption is biologically limited. A Roman slave could put in 100 watts for a sustained period. A healthy person these days could put in the same, but that's it. Whereas EK, the energy that a machine consumes, has grown exponentially since the Industrial Revolution, and quite remarkably so. So you start by, you feed those into the Cobb-Douglas. I've dropped off the A term right now, rearrange it a bit, and what you find finally, there's your alpha is now applied to the exergy of machinery. Okay, so they've gone from a coefficient of 0.04 to one of at least 0.3. And that means that rather than, and that's 10 times the number that they're using. So rather than saying you'll get a 0.4% fall in GDP, you're now saying a 3%, but that doesn't fit the data. That's not close enough. Remarkably, I mean, I'm just covering here, if you haven't read Shake's paper on the humbug production function, I really recommend it. A beautiful piece of writing and beautiful mathematics showing that the Cobb-Douglas production function is simply a nonlinear transformation of income equals wages plus profits under conditions of fairly slowly changing income shares. So of course it fits the national data. But in 1995, Mankiw said, can we make this model fit the international data? And the only way he could do it was by setting the capital share coefficient, not to 0.3 from income shares in national data, but 0.8. Now that ruins the theory of distribution, so nobody's taken any notice of this paper, but this is now 20 times what the economists, the neoclassicals, are using. of course, is much closer to empirical reality. So we find that as I said, it's a one-to-one relationship. So I want to explain why is it one-to-one. If you look at the Leontief expression, you can put it in terms of a capacity utilization factor rather than a minimum LMK as normally is done. So U is the percentage of capital which is actually utilized. Now, V was an empirical observation by Leontief. So I'm going to use K, make the same transformation and put that into the Leontief production function. And now I've got Q, this is widgets per year, the same thing as for the previous model. This is output in energy terms. So I'm dividing energy output by energy per widget to make that conversion. And that then means your EK is now which is the efficiency with which machines turn energy into useful work. That becomes the equivalent of 1/V. So all you need to do in post-Keynesian research is to stop using 1/V and start using e to the k, where v is greater than 2, it's normally about 3, and ek is therefore less than half, it's only about 0.3. And so that's all you need to do with the post-Keynesian theory to make it consistent with the fact that energy is the source of useful work in a capitalist economy. And that's where you get the linear relationship as well between change in energy and change in GDP. Now, I'll just go through and show the impact on this Bachman paper. So he went through showing you, do your differentials, you'll find the change in the log of y will be alpha times the change in the log of e. And on the basis that it was the energy sector was 4% of GDP, then a 10% fall would cause a 0.4% fall in output. You made a little typo there, as you can see. But Leontief says that it's going to be a 10%, and he then says, and I find this quite amusing when you see reality, the spark of reality hitting a neoclassical economist. Intuitively, the Leontief assumption means energy is an extreme bottleneck in production. Yes, it is. This is the essential point. That's why we're in the trouble we are. We've ignored this. You can't produce anything without energy. Okay? So this insight is common sense and therefore a radical expression to a neoclassical economist. Now, when you're not going to, this is, when I first plotted this, I almost fell off my chair. I mean, I expected it to be close to linear. And that correlation there is 0.997. The horizontal is world energy in kilotons of energy equivalent. The vertical is world GDP in 2010 US dollars. That's over a 50-year time period. And that's the change I showed you earlier. So all this talk of decoupling. Decoupling might be happening at a national level because of outsourcing of production, but at the aggregate level, given what India and China are doing, it's still a one-for-one relationship. Now, what I've done with that, and I've actually just quickly run into this, I haven't published this yet. This is work I did with Matthias and Tim Garrett together, but we took this idea of an energy-based theory of production, a single commodity model, and built it into a Goodwin model, which was derived strictly from economic definitions. So if you take the employment rate and take the wages share of GDP, differentiate and feed in a very simple linear Phillips curve, what you get is a cyclical model. This is Goodwin's model, but now including resource depletion, which I've simply added that model. So as you deplete the resources, which you can see happening here, then ultimately you face, for a long, long time, nothing goes wrong, okay? And then very rapidly, in this thing in the last, this is a 250 years, so 150 year simulation. So in the last 20 years, it all goes to hell in a handbasket. And that's where I think we're finding ourselves now. So everything they've done is a waste of time. It's slowed things down. I know Gail has done some work on an alternative, a Keen model basis, an alternative way of modeling the impacts of climate change on the economy. That's worthwhile work, but I think the most important thing now is to forget about all this stuff, take the scientists seriously. We should be trying to stop 1.5 or 2. I think we've got no chance of stopping either, but that's what we should be doing. Forget about trying to measure it in economic terms, work out how to finance it. The private sector is not going to do it. Nudging us via a higher carbon price is not going to solve the problem. We're going to need basically a wartime level of spending, and beyond that, of course, and wartime levels of rationing as well. So we need all the understanding from MMT into how money is created. Government basically finance anything it wants. It's a question of what the resources that exist. So this is using my Minsky software now to show that government spending creates both deposits and reserves. The reserves are used to buy the bonds, so there's no problem about selling bonds on the primary market. And when they're sold on the secondary market to the public, whether that's the non-bank public or non-bank financial institutions, it reduces the money in the private sector. So bond sales, and so like at war bonds and things like that, don't raise money. They take money out of the hands of the private sector and stop spending on stockings when you want to make parachutes, which was the case in the Second World War. And so I think it's important insight from MMT to be brought forward. And if you haven't read that, I recommend reading that paper by Rummel on taxes, revenue are obsolete. We learnt this stuff. We understood it during the Second World War. Neoclassical economists caused us to forget it because it went against their ideology. Now we learn it again quickly to start producing, directing the spending power of capitalism towards reducing the energy that we use currently and reducing the impact of global warming initially. Now, again, just to emphasize that because that's what we face, we're going to go in the reverse direction because of climate change. GDP is going to fall. We're going to get degrowth whether we want it or not. The question is how we're going to manage that. And that'll be long before the temperatures that Nordhaus is talking about. So I think we have to find ways to ration energy consumption. And we need a mechanism to do that, which will put the burden on the rich, because if you put it on the poor, as the French saw, and I think you were there at that time, Gail, the Gilets jaunes riots over a small increase in the carbon tax on diesel. The poor simply can't afford to pay the higher price. So we have to find a way that puts the burden of adjustment on the rich. And a proposal I'm working on with a guy called Adam Hardy, who has an organization called ecocore.org, all not being taken notice of yet, but it's best work that I've seen on trying to make this happen, is the idea we'd have parallel currency. We have money as now, but the government also using things like a digital bank, central bank digital currency, allocate us carbon credits, which could be based on the average level of consumption in each country when you began. And by setting, everybody would, on a daily basis, would get their carbon ration. 90 to 95% of the population would not exhaust that ration. But the top 5% would drastically exhaust it, and to consume, they'd need to buy inputs off the poor, buy rations off the poor. So the whole idea is to enable a transfer so that the burden falls on the rich rather than the poor. Now, I know that's got bugger all chance of being implemented, so the second best outcome would be government transfers, effectively what we're seeing right now with energy in Europe, where the government is using its own monetary creating power, even they're not aware that they've got that power, they're using it to cap prices for oil and gas and energy in general, and enable the poor not to freeze to death. We're going through this cold snap here in Europe right now. Now, can we actually get to 100% renewables before we reach critical levels of CO2? And that depends upon the physical constraints, what is actually physically available on the planet. Some criticisms of some of the key assumptions in it. Work by an Australian mining engineer who now works in Finland for the Geological Survey of Finland. And what you've got here is the amount of energy now generated by non-fossil fuel elements. This is the gap here is the amount that's produced by fossil fuels. So I simply scaled this up and said, if we wanted to go from here, where it's producing about 15% of total energy consumption, to 100%, how many of each of these would we need? And the answer is ludicrous. 800 nuclear power stations and 12,000 new dams, 63,000 new wind farms, et cetera, et cetera. Now, the criticism was that he's exaggerated the batteries, which may affect some of the numbers, would affect some of the numbers here if that were true. But it's to do this in time. And because of this whole thinking in aggregate production function terms, without matter and energy and input, we've ignored the availability of the resources we have. So this is work by the European Union back in 2014, trying to identify elements on the periodic table which are already in short supply. Now, helium and zinc and nemedium we're already running into critical shortages. And that's, they say, at current levels of usage and growth rate challenge in the next, if you know your biology, there's no life without phosphorus. Okay? If you wanted to survive without phosphorus, you wanted to substitute, you need to go to another planet and have evolution follow a different chart. Without adenosine triphosphate, our muscles don't move. And these are other that are also looking like they're in short supply. So we're going to need rationing by both of the resource usage and also the money. This is a bit more elaboration on the idea of a universal carbon credit, which will be tradable. Again, I can't see this being feasible. I can't see it being brought in. But the reason for putting this forward is this is the sort of change which would be popular with the vast majority of the population. So rather than getting the Gilets jaunes reaction, we can't pay, we won't pay, the idea is say, you'll all get the same ration, but Macron will need to buy credits off you to be able to consume. And the people that make the most out of this would be the homeless. So that's the reason to try to put an attractive proposal forward. I don't see any chance of it being done, but I would like to see the structure that makes it possible in place before the crisis hits, which is the reason I support banks, central banks producing digital currencies. So that could be the framework through which that would be the ration cards, the equivalent of 1930s ration cards and 1940s ration cards for the modern world. And government finance will be vital for all this. You will not make a profit out of declining total output. The private financial sector, I think, will be completely flummoxed by this unless government money comes in on a grand scale. So we're going to really see the demise of capitalism because there's no possibility of us financing this using the private sector. Okay? Everything has to be government directed, government run. We're going to go into a war economy and it'll be capitalists, it'll be neoclassicals who destroyed capitalism. And I won't carry on here that much, but some of the things I think we have to conceptually get right is all the nonsense stuff we get back from climate change deniers. In this particular case, focusing upon the Milankovitch cycle that gave roughly every 100,000 years a peak in temperature. When you take a look at the data, where our sedentary civilization commenced was on a turning point around one of those peaks. That's why, one of the reasons why the Holocene has been so equable, so relatively flat. When you're going up a hill and coming down, at that very top point, you're basically going horizontally. So we've had this period, which is a peak on one of these cycles. And without our intervention, we'd be falling back into another ice age now. Instead, of course, we're blasting off into a heat age. And we've only had this, there's only been one previous Milankovitch peak before us 130,000 years ago, something like about, 150,000 years after we evolved. It is just, we don't realize the dependence we have upon the stability of the climate. And it was stable because it was a turning point. And we've now intervened at the turning point and we're blasting ourselves off the scale. So that stability goes, so does the possibility for the sedentary agriculture we've developed. And that's the scary thing. Neoclassicals have no concept of how unusual our particular time in the geological history of the Earth was. Actually, this is a quote I got from I think it was David Pearce speaking at University of New South Wales 40 years ago, which alerted me to what morons they were. What's the problem if it gets 1 degree warmer? I'll wear one less cardigan. That's the way they think about it. So we have to talk about the type of effects you find in the actual science literature, saying what could happen, which you can't summarize in that qualitative way. So this is from Richard Nordhaus about the breakdown of the 3-cell structure in the atmosphere, which we're already seeing substantial signs of. The scariest I've seen is actually by James Anderson, who's professor of chemistry at Harvard. And he said that when the Arctic summer sea ice goes, he argues that alone will be enough to trigger the breakdown of the 3-cell pattern. And when that happens, you will then get storms on the American Midwest, where those storms penetrate the stratosphere and take moisture into the stratosphere. And moisture alone wouldn't be such a problem, but it's going to take chlorine and bromide with it. And he said that will increase the rate of destruction of ozone by a factor of 100, which means effectively you'll destroy the ozone layer. That would mean the Northern Hemisphere in particular becomes uninhabitable. And I've got a feeling that might affect GDP a bit. So this is the horror of our discipline has played a major role in enabling the destruction of capitalism, supposedly the process of trying to defend it. And it's serious. This is a great Australian cartoon from some time ago. Stop laughing, this is serious. But because politicians don't take it seriously and journalists don't take it seriously, really, only a handful do, then they're seeing these things have been minor damages in the far future, worried about by a few greenies who feel very emotional about koalas. In fact, it's more likely to be far greater damages coming soon, and people who are alive today, and even people of my age who are alive today, must see the beginnings of these serious breakdowning along, and we're utterly unprepared for it. So we need strategies that can do something about it, that can drastically reduce the heat we're putting into the biosphere right now. And I spoke at the to this particular group last week, MIR, which stands for Mirrors for Earth Energy Rebalancing, which I think is the least invasive plan that I've seen so far for geoengineering to try to reverse what we've done so far and give us some chance of building a sustainable civilization while we drastically reduce our load on the planet. So that's a little bit of advertising here. I'm an independent scholar these days and I need support from the public. So if you like what I do, help me out there. Let's have a conversation. I'll just actually stop sharing my screen here. Okay. Thank you.
I have a question.
You need to unmute, Clemence. Yeah.
Thank you. So we usually go for questions online first, and then we'll go for questions inside the room. I think Naresh, you said you had a question.
Yeah. I got slightly confused when you showed the damage function slide. So you just mentioned it did not include precipitation, right? Other climate variables except temperature that you were showing the slides to, right?
Not so much the damage, they've related all the damages just to temperature. They don't even have rainfall in their models, so they can't actually predict what's going to happen with change rainfall. So it's just temperature.
Okay. Okay.
I see that Simon, you were raising your hand.
Right. Thank you.
Simon,
thanks for the presentation. I have a question regarding the criticism to the Bachmann paper that I actually read not so long ago. So if I'm not wrong, it's based on the Bakai-Farey paper from 2021. Unfortunately, I think Farey passed away in 2021, so he couldn't rebuke the Bachmann conclusions that came from his paper. But I suspect that if he did, he would probably come up with something that essentially, he would probably come up with other excuses than the production functions. For instance, the model is multi-country but is not spatial. There's only a few sectors. So it would probably come up with a neoclassical excuse. I have two questions. First of all, if you know this paper, do you have other criticisms than the one linked to the production function, which I think in there is a nested CS? And my second question is, when you talk to neoclassical macroeconomists, what sort of arguments do you take to sort of avoid them to just, run away using other arguments, essentially, using other excuses?
Sorry, I lost part of that question. Can you, hang on, what's going on here?
Maybe, Simon, I think your sound wasn't great. So maybe you could type the question in the chat.
It might be better to type it in chat because a lot got lost in the sound there then.
Sure, okay, let me write up.
Okay.
Maybe in the meanwhile, Professor Grasselli, I saw that you were also raising hand.
Sure. Good seeing you again, Steve. And I should say, I also gave a talk a couple of months ago to the seminar online, and it lasted for an hour. But then when I visited them in person, they lasted for 2 hours. They were much more interested in asking things. So you need to go there and see what this group is like in person, because there's nothing like
well,
that.
I've had a suggestion that I should do that. And I hope we can do something about it early in 2023.
Yeah, I tell you, it's nothing like I have ever seen before. It's the most concentrated group doing the kind of stuff that we like to do. So you should go there. For sure.
Yeah, definitely.
But I was following your presentation mostly to see newer stuff that I haven't seen you done before. So I was interested in your comment about central bank digital currencies, because that's something that I'm also interested in. So can you elaborate a little bit more, and how do you see that interaction with the what I call green quantitative easing policy?
Okay. Well, when you look at, I mean, I've used my Minsky software to build a model of government money creation, and I haven't actually, I could happily present that as well. But what I thought when I first did this was that central bank digital currencies would be created by central banks. Now, when you take a look at the financial accounting logic, the central bank could create it and have where the bank accounts are, but the money would be created by the government. Okay, it's the treasury that does it. So to model the central bank digital currency properly, you have to have central banks where the accounts exist for the public, but these treasuries then generating, in the case of a straight CDBC, they'd be putting money into the CDBC or taking it out. And when you look at a carbon credit, of course, carbon credit is not money. It's another form of it'd be another transactional measuring stick. So you'd have to model it properly, you've got to have two parallel structures, one with money and the other with carbon credits. And then the idea would be that everything, like if you buy a product from the, this is just a, I've got an example of some vitamins here, and I get the contents. Okay, we just used to reading what are the contents of products whenever we buy them from a supermarket these days. The carbon content could also be required to be published. And when you bought something, you'd pay that carbon content. Now, what that means is, for the vast majority of us, because the average is so skewed by the wealth of the uber rich, the average for the country would be probably equivalent to the 90 or 95th not decile, but the 90th decile at least. So the 90% of the population would get more in a ration than they were capable of spending. So therefore they'd have excess, which they could sell. And then what you'd have is the public, you'd then have poor people who don't use their entire credit would be able to sell the excess they had to the wealthy who'd needed to be able to fill up their private jets. And that way, that would be an income transfer from the rich to the poor. And also put enormous pressure on the rich and the corporations to drastically reduce carbon content. So that is the key idea of using carbon credits.
Sounds cool. So you modeled that? You had that simulated?
I haven't had time. I've started modeling it, and like what I realized in doing it was you have to have I use what I call godly tables to model financial flows. So to model the private monetary system with government money as well, I need 4 godly tables: one for the Treasury, central bank, the public, and the banking sector. And then to do the digital, I'd need to have 2 more or 4 more tables, or at least 3, for a digital carbon credit currency created by the Treasury, the accounts of that the central bank, and then the holding of that by the public. That would bypass the banking sector. And then, of course, you'd need transfers between when you're selling the carbon credits. Then you'd be increasing carbon credits to the rich, reducing them for the poor. That's a liability transfer. And of course, in the monetary sense, there'd be transfer of money from the rich to the poor in the monetary economy as well. So it's a fairly substantial modeling task, and I think I'll probably get that done early next year.
Okay, so if you want, shoot me a message with that, and we can talk more. I'll be interested in seeing the model. Yeah, thanks.
Yeah, sure. Okay. Looking at Simon's questions, yeah. They actually they reached a conclusion at the end. This is all on the idea of neoclassical perfect competition type assumptions, that it was effectively the same as a Cobb-Douglas production function. So their estimates of the damage of which is using an aggregate Cobb-Douglas production function. And I mean, I don't want to waste my time reading too much neoclassical. I've read far too much for one lifetime already. So if I can avoid reading neoclassical stuff, I will. And because of the conclusions are all drawn from complex production functions, then I didn't bother looking at the Fahy paper as a result. And I'm sick of their excuses. They're always going to have excuses. The real thing is to excuse them from political discussion. So they're never going to convert a neoclassical. Okay, well, there's a few exceptions to that rule, I'm pleased to say, but the vast majority, once a neoclassical, always a neoclassical. And there's no point trying to get them to change their minds. That's been my personal experience, with a few exceptions.
Maybe Grégoire, you were raising your hand as well.
Yes, hi, thank you for your presentation. Yeah, let's say I have 3 questions for you. I'm wondering because as you demonstrated, mostly we cannot estimate the climatic damage function. So it's an issue. It's mostly left for speculation. It can obviously be informed by climatic sciences, but still the estimation of the damage function is difficult. I was wondering, anyway, for instance, Qatar is doing well despite extreme weather, right? But that's because they can use the AC in all of their buildings. And that's my first question. My first question is, do you think that energy or the climate limits will have a greater impact on economic dynamics? Because it seems to me that at the moment there is more literature focusing on coupling the climate issue with macroeconomic dynamics rather than with energy and resource consideration. Also, part of this question, I wanted to be the advocate of the devil and propose that no, actually I wanted to ask you the question, do we know, so we see the correlation between the consumption in energy and GDP, and from a physicist point of view, it's pretty clear, it's pretty obvious that there should be a causality that GDP needs actually reflects that consumption in energy, instead of the opposite, instead of saying that because there is so much income, you see the causality relation would go in the other direction. I wonder if you have some thought on the subject.
Oh, just in terms of when you look at, like, that's why I work with the aggregate data. Global warming is a global problem. And if you go down to individual countries, yes, you can find what looks like decoupling. But at the aggregate level, what's happening in India and China reverses anything in the opposite direction that's happening in the West. So if we go down and start talking at country level stuff, then you can waste all your time. You know, this country's decoupling. Well, it's decoupling because it's trading with other countries. Yeah. So the whole idea that you can decouple, because unless it's actually turning up as a dramatic break in the data, and it's not. When I did a just a very simple, regression between the 2 time series, without forcing an intercept, I got a 0.8, or I think a 1 to 1.2. So 1% change in energy, 1.2% change in GDP. When you force it, you get a 0.8. And the correlation coefficient is actually higher for the 0.8 argument. So the basic summary is change in GDP is change in energy. Okay? It's ludicrously high with annual data at the global level. So I just think, for simplicity's sake, the easiest way to say that the GDP is transformed energy, and not get involved in the debate over decoupling, because if the debate meant anything, it'd turn up in the aggregate data, and as of 2021, it hasn't.
Yeah, most probably the decoupling could be, say, in between energy consumption and welfare. that would be the thing to be aiming at, right? But so I guess that you're advocating for useful energy as being an actual more cleanly defined measure for economic activity, for what GDP is meant to measure.
Yeah, I think it's a very good proxy, obviously. And again, the low level of dispersal around that correlation is remarkable. So even again, simplicity, make simplifying assumptions, not critically false assumptions. And the simplifying assumption is GDP is energy.
I have two more questions. I wanted to ask you maybe for some retrospect on your most well-known paper on modeling Minsky's financial instability hypothesis. I'm wondering why is it actually so I was trained in physics. I started studying economics just a little bit more than 2 years ago for my PhD. So I'm still discovering the whole broad field and variety of communities. And I'm wondering why was it not more widely accepted? Why is it that neoclassical economists cannot accept the possible existence of multiple equilibria beyond these that represent a growth path of balanced growth?
Because it's a religion. Yeah. Because it's a religion. Okay. I mean, like my favorite instance of this is actually related to cost of production. If you look at the research done into what the firms face rising or falling marginal cost, the answer is overwhelmingly falling marginal cost, not rising as an economic theory. The last person to discover that was Alan Blinder in 1998 with a book called Asking About Prices. In the results, he said the overwhelmingly bad news, brackets for economic theory, is that the vast majority of manufacturing occurs with constant or falling marginal cost. So that's him empirically saying it's the opposite of what's said in the textbooks. Okay. Well, he writes a textbook. Did he include his own results in his own textbook? The answer is no. Okay. Because the effects of doing it would be to destroy the whole theory. So therefore they find a result they don't like, and even if they find it themselves, they ignore it. That's the behavior of a religion, not the behavior of a science. So, that's why they simply won't look at what the work that myself and Gail and Matthias do, because we breach their core assumptions, and therefore it's not even on their mindset. You would have seen Bernanke getting the Nobel Prize recently for loanable funds in 2022. And the entire document, the scientific report document, did not quote one element from the endogenous money literature, including even the papers from the Bundesbank and the Bank of England. So they read what they want to read, and therefore they wouldn't even know that our papers exist. I expect most of them.
Okay, that's depressing. Last, somewhat related question. I think it was at the end of your last book, the New Economics Manifesto, that you were giving some advices to students interested in the heterodox streams of economics. And well, you were giving advices on how to survive, like going to smaller universities or to department of not the economics department, but say the department of public policy. But so you made it to UCL. So has a change happened, or do you sense some incoming change into accepting perhaps a broader scope of what economics is meant to study, and also a broader range of methods?
Well, my main argument was any intelligent person who wants to work in economics should study system dynamics instead, because at least it's generally applicable and it's the right methodology for analyzing dynamic systems. And you're far more likely to get a decent job out of system dynamics now than out of economics. So the academic world has become absolutely awful for not so much in America, I think, but certainly in Europe. It's an unpleasant profession to be in these days. And but once you're trained as an economist, what else can you be? But if you learn system dynamics and apply it to economics, then you can work in all sorts of different areas. and apply a better technology to economics when you work on economic issues as well. So I mean, you know, I just don't see any point in wasting your time learning neoclassical theory, which is all you learn if you go to a conventional economics department.
Okay. Thanks.
All right. Are there other questions online? Or can we turn to the room? Okay, so here in the room, I think we've got Paul who is willing to ask something.
First, thank you for your presentation. Former physicist from system dynamics who switched into economy, so I followed the path unconsciously of just what you described. My question would be mostly toward multisectoriality and what is hidden inside those aggregates. So you've shown this importance of energy into a production function. My first question would be, why not simply using Leontief production function, but rather than having two production factors, we just have three, and just the energy, which is in fact a kind of hidden intermediate consumption of the GDP production sector somehow. So that would be my first question, which in fact, if like we consider energy, we just have hidden an energy sector inside our system. The second one is you've shown this very impactful correlation between GDP and energy. My assumption was, it's at the world level. Do we know if the correlation slope is exactly the same for all the countries and all the regions? And so does some different economics has a specific slope and energy consumption per unit of GDP? And my last function is you've also a question.
I might answer the first two before I forget the first one when you ask the third. Okay, I think one reason with the Leontief, the single commodity thing, was actually Mateus. He insisted we try to produce a single commodity model. I thought we should be going for multiple commodities immediately. I had to concede Mateus was right. It worked much better to have a single commodity model for some of the insights we get out of it. But fundamentally, of course, you're talking an input-output system. And one thing I would like to see us developing is like an energy versus version of Schaffer, rather than reducing everything to dated labor, reducing to dated energy. Okay? And then that would be the new way of having a sort of Schaffian understanding of production. And it's evolutionary as well, because you have change over time. So to properly model it, you'd want to have, you know, tensor mathematics being used and breaking it down into different sectors with, of course, different energy usage elements as part of it. And the data is definitely, it's global data, but that data set that I showed includes country level data as well. So you can see the dispersal, and the dispersal is quite wide. I mean, there are some countries where the energy is rising faster than GDP, others where GDP is rising faster than energy. The average comes out in the middle, and a large part of it is because of the relocation of production from the advanced countries to the third world over that time period. We're looking 1980 to 2017, or 2021 in that database. But that's fundamentally the huge period of relocation of production from North America to China. Take a third question.
And so the third question is on damage function. So you've shown that indeed, given the actual data, we cannot extrapolate anything with a polynomial or with any shape of function, because we are still into the linear parts before the real trouble begins somehow. What would be the alternative? Should we drop the notion of damage function as polynomials or as any type of function? Should we try to disaggregate it to have specific sectors impacted more like from data from the second group of the IPCC? How can we do better than just trying to extrapolate things that we cannot extrapolate for the moment?
Well, I think the damage function was the way that Nordhaus destroyed the limits to growth. And that was a system dynamics model that had, you know, the old physical constraints and, you know, feedbacks between the different system states of the global model. That's what we should have been doing. Okay. I think it's too late. The people who work in that have almost like become, you know, Stockholm syndrome given the barrage of attack they've copped from the Nordhaus faction. So the limits to growth, the latest rendition of that, has completely changed the way that they model different sectors to try to get around the complaints about not having a price sector, not having utility, et cetera, in the model. I'm actually not very fond of that. I think we should have actually said that limits to growth is the right way to go. Let's just generalize the level of interactions and get better data and fit it better to the data. That's what we should have done. And of course, if you look at the limits to growth projections, they were pretty much saying you're going to start seeing a decline somewhere between 2020 and 2050. And that's what we're seeing. So if you look, I'd recommend looking at Gail Harrington and Graham Turner's work on how well the limits to growth fits the data. And the answer is too well. So that's what we should have been doing. But now I think, given we've wasted 50 years, courtesy of neoclassical economists on this, there's no real point in trying to get a better prediction. By the time we do, the time it would take to build a better model and the time to get that information, we'll all be in a climate crisis, first order climate crisis. So the most important thing, I think, is to start modeling how do we finance the sort of changes we need, and how do we quantify the physical availability of resources that's needed to make a transition from a fossil fuel-based energy system to non-fossil fuel. And that comes down to the whole uranium versus solar. It comes down to how fast you can roll those things out. Clearly, solar can be rolled out faster than nuclear right now. But we need to do everything we can to reduce our carbon pumping into the atmosphere. We need to do everything possible to reduce the energy we're absorbing into the atmosphere, which is why I like the Mir proposal, even with the unintended consequences it's going to have. Those things have to be the focus, not trying to get, oh, we got it wrong, let's try again. We've got 20 or 30 years to get it right. No, we haven't.
Okay.
Yeah. Thank you, Steve, for your presentation. I had actually a comment and a question for you. The comment was on the question raised by Grégoire, I guess, about causality between energy consumption and GDP. There are a number of countries, even though I don't remember which ones, but I've seen the graphs for which you see clearly first reduction of energy consumption and then a reduction of GDP. And so this is a sign that there is a causality between energy consumption towards GDP. So that's one comment on this. My question was about your suggestion. I mean, the digital currency idea. It seems to me, I remember there has been an experiment in this direction just before, I think, 2007 in the UK, with something like maybe 1,000 citizens. So they received a kind of card, a carbon card. They were allowed to spend a number of carbon units, and they were told how much the average of the sample would spend in terms of carbon. And even though they still didn't have the budget constraint, which was supposed to be the second step, what we observed is that they were already reducing their consumption of carbon just in order not to be above the average of the sample. So this was a very funny experiment showing that.
The acoustics are rather bad, but my hearing is bad too, Gail. So can Clemence try to just repeat that so I get the question right? But being near the speaker is the issue. Yeah. Thank you. Thanks, Gail.
Can you hear me this way?
Much better. Much better.
Okay. So I was just alluding to the fact that it seems to me there has been an experiment in the UK just before the 2007 crisis, where they have taken, I don't remember, a sample of, let's say, 1,000 citizens who received a carbon credit card. They were allowed to spend this. And so they did not go very far because then the financial crisis came. But what I remember is that they observed that, let's say, every week they were communicating to the members of the sample how much they had spent on average in terms of carbon units. And then it happens that those who were above the average were trying to reduce their carbon expenditures just in order not to be above the average. So they felt guilty, you see. So even though they didn't have to spend real money, just the fact that they were informed, oh, you consume more than the average of the sample, make them feel guilty, and then try to reduce the consumption of carbon.
That sort of thing is useful. I mean, we're going to need that, but I want to drastically increase the pressure there, because it's not really our consumption, the bottom 80% that hits the aggregate level. If we could reduce the consumption of the top, I don't know the actual figures here, but if you reduce the carbon consumption of the top 5% by half, which is quite feasible, they could handle a 90% fall and still be living a damn sight better than we are, then that would be probably like reducing our carbon consumption of the aggregate by 1/3. So the biggest gains that are feasible are to reduce the consumption of the rich. But of course, that's not exactly what they're interested in doing. So we won't get anything like that until the politics is such that, again, like in the Second World War, people accepted rationing because any conspicuous consumption then meant you were taking resources away from the war effort. And we need the same sort of mentality this time round. That'd be intriguing. I'd like to see that study though. So if you know any link to it or any, just send me a footnote and I'll go an email. I'll go check it out.
And actually, if I may just add, there was a similar experiment that was made in California because they have, well, a lot of problems with water availability. And so they have launched an experiment where they disclosed to households their level of water consumption and how they ranked compared to other households. And they found similar effects for people around the mean. So people that were just a little above tried to use a little less water so as to be below the mean. But sadly, so that might be an argument for your solution, Professor Keane, the people that had the higher water consumption would just stop doing any efforts because they were discovering that they were anyway just like the worst consumers. So I don't know, they probably felt overwhelmed by that. So it had the contrary effects on that precise top part of the population that we are interested in. So yeah, that's.
And Gregor.
Yes, thanks. I had the last question that I remember at the end of when I was talking. I would love to have your reflection on just 2 sentences by Kenneth Boulding in his book Economics.
Oh, okay. Yeah. Okay. Yeah.
So honestly, I'm also a partisan of the dynamical system approach to macroeconomic modeling. So that you advocate, that I think probably was initiated by Ragnar Frisch even. That was a lifelong concern of Richard Goodwin, that has been advocated by physicists, and I'm a former physicist like John Blatt or Philip Anderson that you know well about. So I'm rather a partisan of the approach. But the other day, maybe 3 days ago, I was reading this book and I would like to comment on what he writes. So this is what he writes. He writes, a good deal of time has been spent by economists, especially, in trying to develop mechanical models of the business cycle, somewhat along the lines of celestial mechanics. On the whole, these have been a failure, mainly because the business cycle itself is a very irregular phenomenon with strong random elements in it, and thus does not conform to the patterns of simple different systems. Maybe you didn't know about chaos.
You didn't know. No, that's a pretty complex system statement. And this is the common thing. And most economists in general don't understand complex systems, of course. Anybody who thinks he can model equilibrium doesn't understand complex systems. But it also, even some of the critics predated. So if you look at Hayek, he said, systems are complex, therefore we can't model them. By complex, he meant complicated. Now we know complex actually means nonlinear interactions from a relatively small set of system states. So once you have that, you get irregular cycles. And if my Minsky model has sort of melodic cycles in one sense, if you like, they decline and rise all at the one time. But I include a government sector, then I get quite complex cycles coming out of effectively a 3-dimensional model with 4 sectors to it. So the fact that you can't get the irregular cycles is with the Goodwin model was because it had a neutral equilibrium. It therefore couldn't give you varying cycles. That's just an artifact of that particular model. When you generalize it, you get complex systems of behavior and aperiodic cycles.
So what's your take on the method? Can we expect to be able to make forecast, or do you use it principally as a tool to just make sense of the world? And actually the only prediction, but which is very important, of your 1995 paper would be that it can be understood from a dynamical system point of view, that there could exist an equilibrium, attracting equilibrium, which represents not a path of balanced growth, but a path of debt deflation crisis.
Yeah. The main thing that comes out and says you've got to include, if you've got to give credit in your economics. That's the main benefit of that 1995 paper, that once you have credit, you get a form of instability that can cause a breakdown if you let debt levels get too high and the change in debt be too high. So it isn't so much prediction as saying what your important elements to properly characterize the economy are, and leaving money out of a capitalist economy is a mistake. And that's what neoclassicals have done, of course. So you can still do some degree of prediction, but I think it's mainly characterizing rather than predicting. And even so, you look at what has happened with weather forecasting over the last 50 years. They've gone from being inaccurate at the 4-day level to being inaccurate at the 2-week level. And that's partly because, of course, they're working with non-biological components in their models, but also because they've just refined their predictive capability over time. We could imagine the same thing to some extent, but the most important thing in that paper was identifying the critical role of credit in economics, and that's left out of mainstream models. So if you leave out a major determinant factor, of course, all your predictions are useless. You'll fit the data until there's a change in the credit trend, and then it falls apart. And that's what happened in 2008. But overall, I think it's mainly a descriptive role rather than predictive. I agree.
Yeah, thank you for your reflection.
All right. Is there any question left? Well, in this case, we are pretty much at the end time of the seminar, so I think we should stop there. Thank you everybody again for attending, and thank you in particular to Professor Keen for accepting to present today. That was really a pleasure for us to host you. And just as a reminder, this is our last 2022 session, but we'll start again very soon in 2023. As on the 5th of January, we should have a presentation by Adrien Guenu, who will talk about a stochastic financial market module for stock flow consistent models.
When is it?
January the 5th. So that's the first Thursday. All right. So I wish you all happy holidays and see you soon.
Okay. Bye all. Bye-bye.
Thank you.
Bye. Thank you for the presentation.